All right, so here was a question from quiz 5. This was also a question that came from the homework, so hopefully it looked somewhat familiar. And on the quiz, we really had two different things we were looking at, either types of error or something from 16.1, which was looking at different elements of two different samples and their means. So we have two different samples, original hot dogs and new hot dogs. And we're doing confidence intervals ultimately, but here we're asking specifically for the margin of error. So that that was part of this, is just making sure that you were looking for the right thing. So let's go over to our calculator. So we do have a formula for this in the notes. That's absolutely true. However, with most of the stuff we're doing in chapters 15 through 18, you pretty much want to say, is there a way to do some of this, or at least most of this, right? Most generally, oftentimes we can do all of it in our calculator. So, all right, so let's check this out. If we go to, let's say we have two lists, right? We have the raw data. So go to stat, and then if you hit edit, you can put all this information in list 1 and list 2. I've already done that because it's just otherwise going to be boring to watch me put those in. So put the original hot dogs in list 1 and the new hot dogs in list 2. And then if we go back to stat and then over to all of our tests, so tests and intervals. Well, margin of error has to do with a confidence interval. And so this is a piece where remember that if we have a confidence interval, so if we have some sort of interval like this, we have a lower bound and we have an upper bound, and in the center of this is our point estimate, whatever our statistic is. So in this case, that would be something like x1 bar minus x2 bar, right? That's our estimate for the real difference of the means. Well, how do we get to the lower bound? How do we get to the upper bound? We go a distance m. We go that margin of error m. So what does that mean? Well, okay, I guess that means that the entire interval, if we find that length, it's twice m. So let's go back over to our calculator here and say, well, let's go find that interval. We've got two samples, so then we just have to choose between z and t. Listen, most of the time we're going to be using t because we don't realistically have the population standard deviation. So most of the time it's t. If for some reason we have the population standard deviation, then use z. But this is a two sample t interval. We are in data here, so list 1 and list 2 for our two different samples, and then we just want to update our confidence level. So in this particular case, we want 90% confidence, so 0.9. You may have had one of the other versions of this, so maybe you were looking at 95% confidence. So adjust this as you need to. That's maybe also a good note. If you got some of your questions wrong and you were working with someone, that's because I'm randomizing these questions. So keep that in mind. All right, pooled, we usually say no, these are not pooled. And then let's calculate this thing. So what we know is we're going to be given a lower bound and an upper bound here. We're also given some other pieces, right? We're reminded of sample sizes and individual standard deviations. So yeah, we have the formula. We could actually use those as well. However, again, this is the fastest, most efficient way to do this, is to look through and say, okay, well, what's the entire length of our interval? Well, okay, that's the distance from the lower bound to the upper bound. So usually we would just subtract. We would say 2.1662 minus negative 0.00662 or 0.0062. So be careful about the fact that we have to subtract the negative. Right, you can kind of think about that. What would we do if we had two positive numbers? We would say, the lower bound is 2, the upper bound is 10. We would do 10 minus 2. So it's still just upper minus lower, and you can put that as a generality if you want to. So if we do this, right, we can punch that up. We can say 2.1662, And you can either do minus the negative, or you can say, hey, those two negatives are going to turn into plus. So plus 0.0062. If we do that, we're going to get, right, the entire length is 2.1724. So what is m, right, the margin of error? This is going to be half of that distance. So it's going to be 2.1724 divided by 2. And again, if we just come over here, what we can do is just say divide by 2. And it's going to take your previous answer, divide it by 2, and you get 1.0862. And this was ultimately the answer that we were looking for. If you had 90% confidence. Again, if your confidence was different, it would be something else. The other part of this is this value, it does have units. So I usually ask you to leave those units off in the quizzes, but it's worth noting, right, our point estimate is a difference of mean grams of fat. And our margin of error is also going to be measured in grams. So technically this is 1.0862 grams. The other piece is, please be mindful of how many decimal places I'm asking you to round to, because I do build in a margin of error for your answers, but it usually is based on this very last decimal place, or maybe in this case like the third decimal place. So if you're just rounding to like 2 decimal places, that could be trouble for you. So please be really careful about that. And again, just make sure you're double checking things like, what level of confidence do I have? Maybe double check the values that you entered, things like that. Okay, that's pretty much it.